Okay, and here's the first of the extra questions I gave, which was to use Excel to approximate x of 2 for the IVP x double prime minus x squared equals 0, with initial conditions x at x is 6 at 1 and the derivative is minus 12 at 1. I actually concocted this example. Typically you can't solve these equations, but the solution for this happens to be 6 divided by t squared. So that means the correct answer is 1.5. So first by hand you had to do it with the delta t of 0.25, and so you would have written down something like this. So here is my x6, and x prime is minus 12, and the second derivative is 36, 6 squared, okay? And so then we just update the new x by the same method using Euler's method, which is the new value equals the old value plus the rate of change times our time step. And the same thing for y, and the derivative for y, of course, is figured out from that being x squared. And so you would have gotten an answer like 2.19. How are you supposed to get it correct to 2 decimal places if you don't know what the correct solution is? Well, this is the way that people have been doing it for centuries, and that is you do some work, you get an answer, you then do a better approximation, you see what the answer is, and then how the solution stabilizes, that tells you that the answer is correct to so many decimal places. Okay, so for example, if we let delta t now be 0.01, and we copy and paste, we see that at 2 we get 1.54. Okay, and then if we do 1,000th, go ahead and copy and paste again. And we find 2 again, and we get 1.50 this time, okay? And so we see that the answer is getting more and more accurate as we're going along. We don't know what it's going to, but we see that the answer is sort of stabilizing as we go from the left. And so then if we try one more, let's try 10,000. And then this is a whole bunch of work. So this, we should be able to see some kind of answer very close to 1.504, which we remember was the answer that we saw before. And we're almost there. But of course, that's the trouble with Euler's method. It's you need to do lots and lots of steps to get really accurate answer. And here we go. We try and find 2, and it's 1.5004. We see that sort of stabilization happening, and so we're quite comfortable saying that it's 1.50 to 2 decimal places based on the stabilization that we have seen. Okay, on to the next question. Last question.